All right, so this is going to be lesson 6. So it's unit 1, lesson 6, part 2. So what we're going to talk about now is looking at using scientific notation with decimals. So you should have had some practice questions that you did for using whole numbers. I think you guys had 23 million in scientific notation, and it ended up being 2.3 times 10 to the 7th. Step 1 was to place the decimal point between the 2 and the 3. Then you multiply by 10, then you count the number of digits, and you did that again for 506,000 and 70,020,000. Now we have to look at what happens when we have a decimal. So, and we're going to talk about too, changing from scientific notation to standard notation. So before I get ahead of myself, let's talk about changing from scientific to standard. Remember that standard is just how we normally write the letter, or number, sorry, how we write the number. So when we have a number that says 5.17 or 5 and 17 hundredths, and we say times 10 to the 6th, I think that's the example that they give you, times 10 to the 6th, then what we have to do is this. We have to look at the number above and to the right of the 10, this exponent, remember? It's going to tell us how many times we're going to multiply 10 by 10 by 10 by 10, and then we would multiply it by this number. Well, an easy way to do that, because our number system is already set up by tens, so it takes 10 ones to make a 10. It takes 10 tens to make 100. It takes 10 hundreds to make 1,000. And it's the same way. It takes, 10 hundredths to make a tenth. It takes 10 thousandths to make a hundredth. So when we look at this, we're going to move the decimal point the same number of places as our exponent. So we're going to move the decimal based on the exponent. Decimal based on the exponent. So on this one, we're specifically going to move 6 places to the right. 6 places to the right. So here we are, we have 5.17. Well, what do we do in these places to the right? Well, remember, in a whole number, we were able to keep the zeros, and in a decimal, it means the same thing if we have a whole bunch of zeros there. So we didn't really keep the zeros. So we can put as many zeros here as we feel like we need. We may not use them all, but we're going to take and move this decimal 6 places to the right. 1, 2, 3, 4, 5, 6. Now we don't need these extra zeros on there. So let's write this number with the decimal place moved. 517 with 4 zeros. 1, 2, 3, 4. To find out how to read this number, we start from the right and we put commas in every third place so that we have our families together. So 1, 2, 3, comma, 1, 2, 3, comma. This number is read as 5,170,000. The zeros went in all of the spaces to the right to hold the place value. So this is 5,170,000. So there are a couple examples that they have you walk through. So let's just do an example of our own. So we're not really even getting into um, decimal points a whole lot yet. All we're really kind of getting into is whole numbers, how to make them decimals, and how to make our decimals into whole numbers using expanded notation. So it's the switch between scientific to standard. And so if I had the number 4,657,298, to write that in expanded or scientific notation, I would go in and put the decimal point between the two largest place values, or the first two numbers. So that's here. So it's going to be 4.657,298. My next step is to put times 10, and then to count how many times the decimal place was moved. 1, 2, 3, 4, 5, 6. So this number, 4,657,298, is written as a decimal 4.657,298 times 10 to the 6th. That's going to standard notation, or scientific notation. So we move from standard to scientific. Let's practice one moving from scientific to standard. So we can go back and forth all day long, right? So let's do 8.57132 times 10 to the 5th. So all we're going to do is we're going to take and move the decimal to the right 5 times. 1, 2, 3, 4, 5. So our number is then 864,957.132. 1, 2, 3. Okay. So notice we can have a decimal point and not be in scientific notation. Scientific notation is just when you have that 10 to the 5th with the base with the exponent. In this one, we moved from scientific to standard. 8.64957132 times 10 to the 5th is actually 864,957 and 132 thousandths. I know that seems like a lot, but you can go back and forth easily between the two. You can go back and forth easily between the two. As you go into your actual assignment, it's going to ask you the 3 steps to writing a number in scientific notation. Please look back at your notes because we talked about those. And then the next question is going to say, use those 3 steps to write the number in scientific notation. So it's wanting you to not only know the steps, but to be able to apply them. So remember, with a number like 720,000, your first step is going to be to place the decimal where it belongs. So place the decimal. I'll give you a minute to think about that. Remember that you're going to place it between the first and second digits in the number. So you're going to place the decimal 7.200000. 0. So that's step 1. Remember that step 2 is to multiply by 10. So we've got 720000 times 10. This is step 2. And then step 3 is actually going to be getting rid of some of those zeros and creating our exponent. So 7.2 times 10 to the 1, 2, 3, 4, 5th power. 7.2 times 10 to the 5th power. This is step 3. All right, you'll complete the rest of this assignment on your own. Please stop by and see me if you have any questions. Thank you.